So in a previous video, we talked about the area formulas for some basic shapes, and one of them was a right angle triangle, just like the one you see here that's got a base and a vertical height. And I know it's right angle because it's got the little right angle symbol, but what about, well, sorry, first of all, we said the formula was half times the base times the vertical height. So I need to know a base and I need to know the vertical height. Substitute them in and I can simply work out the area. All right, so far so good. The base is across here and my vertical height is here. I just substitute those values in. But what about if I've got a triangle that's not a right angle? Something like this one here. Well, I can pick a base. So in this case, I'm going to pick the one on the bottom here as and say, look, that's my base. I'm then going to draw a line that runs perpendicular. Now, perpendicular, hope you remember, means at 90 degrees. So a line that is perpendicular that reaches the other vertex, or the other corner of the triangle. So if I put that in here, it goes from the base at 90 degrees across and touches the tip or the vertex of the triangle on the other side. Guess what? That's my vertical height. Awesome! Now I can use my formula. I've got a base and I've got a vertical height. Okay, I substitute those values in and it's good to go, just like I was using as if it was right angle. Okay, so remember, it goes from the base at 90 degrees. Now, but what about if does the base have to be the one on the bottom? What if it's not? Well, what if it was this one? Doesn't matter, exact same idea. I take a line that runs from that base at 90 degrees across to touch the vertex opposite. And now I've got a base and a height. That bit becomes my vertical height. Substitute those into my formula. If you're given something, the base doesn't have to be on the bottom of the diagram. It's just the way that the picture or the book shows it. Okay, it can be anywhere, but the vertical height always comes from the base at 90 degrees. Same deal if I went with this one. Over on this side, I take a line that runs at 90 degrees across to the other opposite tip or vertex of the triangle, and now I've got a base and a vertical height, and I just substitute those into my formula. Okay, hope that makes sense. What about, though, something like this, which is an even weirder looking triangle? Where's my base? Where's my vertical height? Now, usually in a textbook or an exam type question, you'll kind of be given something like this. Something that shows outside the triangle that actually represents a base and a vertical height. How do you know which one is which? Remember, the base and the vertical height meet at 90 degrees. So in this case, the base would be this side here because I've got a line going at 90 degrees from the base. That, hopefully you can see from the other diagrams, is our vertical height. Okay, so just going back there, you did see that I needed to finish off a line that runs sort of straight along to join the other side of the triangle. Okay, I've got this external value here. This is my vertical height because it's the line that is perpendicular to my base. Okay, just like we did in that second example. And I can now put that into my formula. They're kind of the hardest ones. They're the trickiest ones, I reckon. These ones where the vertical height is actually outside, but the base is going to be the one that meets that height at 90 degrees. Really important you remember that. A couple of last little bits of info. This one, because it's got a right angle symbol, I know it's what we call a right triangle. This one, every angle inside this is less than 90 degrees, which hopefully you remember are called acute angles. So this is called an acute triangle. Finally, this last one, this black triangle, has one angle in here that's more than 90 degrees. That is obtuse, so we call that an obtuse triangle. Okay, they're the three different types of triangles you might get where you need to apply the area formula, half base times height. You've just got to identify where the vertical height is. It might be inside the triangle. It might be outside. Good job.